Divisibility is a pretty basic concept. If we're looking at divisibility, what we're talking about is that if D divides N, which is the larger number, D or N, do you think? Just look at what it's saying. D divides N. What's the largest? N is the largest. The larger. Unless they're both equal. They could be both equal, but D divides N. Normally, D is the smaller. So if we're looking at it as a fraction, it looks like this. D is the divisor, and it divides into N. Okay? Now, if it does divide, we can say N is equal to D times some constant where K is an element of the integers. And that is the main idea in this whole thing. All the proofs that you're going to do, whenever something says it divides, you can just say, okay, the larger one is going to be the smaller one times some constant K. Does that make sense? And all our proofs will work this way. You can see some properties. We're going to prove a lot of them, so I'm not even going to go through them. But it all comes from this idea that when you say divisibility, a constant is going to be put into the mix times the smaller of the two. Okay? And these are the same divisibility properties. They have an example here. Let's just do it. And then we'll do one together. I like this one. Transitive property. D is divisible by N, and N is divisible by M. So D is divisible by M. So which is the larger one? I'm going to put a star next to the larger one. D or N? N is the larger one. Which is the larger one, N or M? M, okay? So N is equal to D times, we'll call it K1. What's M equal to? N times K2. And K1 and K2 are elements of the integers. Okay, and they'd be positive integers, probably. Okay, now, if you put this N in for N here, you're going to get M equal to N, which is D times K1 times K2. So M is equal to D times K1 times K2. And if K1 is an integer and K2 is an integer, what will K1 times K2 be? Yeah, this will be an integer. So, since K1 times K2 is an integer, then which is bigger, D or M? Which is bigger? M is bigger, so we would say D divides M by definition of divisibility. Okay, so let's clean this up a little bit. How do you start a proof accurately? Well, the first thing you want to do is to list what's given. So what they did here is they said, since D divided by N, there exists a K such that, and we did that. N divides M, there exists a K2 such that that's the case. I'm going to take these out so you can see them. And then you can see how they substituted that. Therefore, D divides M. So that's a proof of transitivity. Kind of neat. Let's do one from scratch. See what you can do with 6. We start the proofs given. A, B, and C are elements of the integers. And A is not equal to 0. And then I'll help you out. You start with A divides B and A divides C. What does that imply? So these are the big ones, right? So what's B equal to? Yep, K1 times A, where K1 is an element of the integers. Good. And C is equal to K2 times A, where K2 is an element of the integers. Now what? Rearrange some stuff. What do you mean? Okay. So with this one here, I think you're close.
So you can add them together by A.
Okay, so we could add these. So B plus C is equal to K1A plus K2A, right? And so B plus C is equal to A times K1 plus K2, where K1 plus K2 is an element of the integers because each of the individuals were. So what does this imply? Yeah, so this is the big one, right? So we can say that A divides into B plus C. What do you mean plus or minus C? Right, so we did the plus. I think you have to prove the minus one, don't you?
I mean, if you have a factor, then it's a matter of K1 minus K2.
Yeah. Yeah. And it still would be integers. So yeah, I agree. So there you go. There we prove the divisibility.